The Model 6760 moisture probe supplied with the eGauge uses electromagnetic technology. This technology detects the dielectric properties of the material around it and equates that to a moisture value determined at the time that the probe was calibrated. There are 3 general moisture calibrations stored in the memory of the eGauge, which are useful to get a moisture measurement displayed on the gauge that is usually close to the moisture value of the soil material. This is found in the Setup menu under Option 8, Moisture Probe, and Option 2, Cal Profile. The default is General, number 1, and that is used on most soil types. If you have a very clayey soil, you would use Option 2, and a true crushed aggregate subbase, you would use Option 3. This will get you close to the moisture reading of that material. However, an offset or a probe calibration specific to your soil is needed to get an accurate moisture measurement. There are almost infinite soil types, grain sizes, soil makeup, mineralogy in existence on Earth. Therefore, it is nearly impossible for the probe to be calibrated to the soil that you are measuring at your job site unless it is adjusted to that particular soil. When a relative value is being measured, such as dielectric properties, a field offset or soil-specific calibration is necessary. There are 2 ways to adjust the moisture probe to more closely match your specific soil. The moisture offset is the simplest and most common method. This is available under the offset option, and it's number 3, moisture. And to create a new one, you would select 1, change. We'll discuss the procedure in this demonstration. A moisture probe calibration is another option. This procedure creates a new moisture calibration profile, which is then stored for later use. This is in the same menu we looked at earlier: Setup, 8, Moisture Probe, and 3 would be Probe Calibration, and 1 would be Create a New Calibration. And we'll discuss that procedure. The benefit to the moisture probe calibration option is that it forms an actual calibration which will address the adjustment of the moisture readings at various moisture levels. If the soil has a wide range of moisture contents, this is a better option. The moisture offset adjusts the reading at the moisture level which the offset was determined for. This is often acceptable because it is common and desirable for the moisture content of a soil to be near optimum. You will have to first perform the measurements in the field with the eGauge and the moisture probe. Then remove a sample of the soil at the same location and seal it in a bag or bucket until it can be dried in the lab. If you are able, a field dry on a portable stove is also an option. Remove the sample at a depth of 3 to 5 inches below the surface to sample the same material that was read by the probe. Remember to record the proper data from the gauge display and name or number each test location so that the gauge results can be matched with the lab results for calculation and/or entry into the gauge. It's always a good idea to store your readings in the gauge memory so that you don't lose these results. Once the lab dry results are obtained, the data can be entered into the eGauge and a moisture offset can be enabled. You access this through the offset menu, moisture offset, 1 would be change, and you go ahead and enter the data as shown in the sample here. It asks for the moisture content. In this example, it's 11.38. And the wet density, which is in this example 132.64. Enter. And then they want the true moisture, which is your lab result, and that in this example is 13%. And then it calculates your offset. and it enables it, and you're ready to go. The offset will be disabled if you turn the gauge off for any period of time, but if you go to use the gauge on a different soil that doesn't require this offset, you'll want to disable it yourself. The other option for correcting the moisture readings is a moisture probe calibration, which is accessed under the Setup menu, under, let's see, Moisture Probe, which is number 8, and then Probe Calibration is number 3, Create a New Calibration is number 1. You can either do keypad entry, which is what we will do in this example, or gauge derived, which means you will take the readings in the field, store them as a partial, and then bring your samples back into the lab to dry them and enter that data later. So it's your choice which one to use, but we're going to use keypad. We've already collected the data in the field, recorded it, and oven dried our corresponding samples for each site. You can have between 3 and 25 sites for this procedure. I have done 5 test sites. We recommend at least 5, and it's good to have a wide range of moisture, percent moisture values for these sites. We recommend at least 5% to get a good calibration. Okay, so we're going to use keypad entry with our data. So our sample data, starting with site 1, we have 5 sites. Starting with site 1, we'll enter the percent moisture, which is from the lab. In this example, it's 9.8%. Now they are asking for the wet density, which is 115.4. Then the diff value, and that is 7541 for sample 1. Okay, now we will go enter. True moisture 11.8. Wet density 118.5, and the diff is 8138. Okay, enter for the results, and it shows the slope and intercept and the R squared, which is all good. The R squared, the closer to 1 the better, so we will go ahead and save that. There are user profiles for you to select. We're going to use number 1, and you may want to make a note for this soil type. It's stored under user profile 1, so you can come back to it when you come back to this soil type later. Activate the profile. I will press yes, and it's enabled. So you will only be able to use this on the specific soil type that was sampled for this probe calibration.